We began by researching how breadboards and Arduino work. Once we got a general idea of circuitry and Arduino coding, we started to look at codes and circuits specific to buttons and LEDs.
We started to make a simple one button and one LED circuit, failing a few times before getting it to work. We connected the breadboard ground to the ground blue column. We then put a 220 ohm resistor in pin 11 and the other side of the breadboard in row 11. Next, we attached the positive side of the LED to row 11 and a negative side in row 13. We then grounded the negative side of the LED with a wire to the blue ground strip. We then placed the button so that it was connected to both sides of the breadboard and powered one corner to 5 volts. We had to ground the button as well, so we used a pull-down resistor and grounded it. We also connected the grounded row to pin 2. We used the button example code on Arduino to help us, and in the end, it simply turned the light on when the button was held down.
Next, we had to figure out how to keep the light off or on when the button was pressed, like a light switch. Originally, we did this by adding a Boolean component to our code. However, we removed it, which will be explained later in the video.
Our idea for the project was that if we pressed the button, one light would turn on while the other turned off. So we added another LED in the same way we did the first. This then finished our circuit, so all we had to do was edit the code. In order to switch the lights, we wrote the code so that that when the button was pressed, one light was on high and the other light was on low. The states would switch once the button was pressed again.
Lastly, we had to debounce the button because the lights would flicker when the button was pressed. We used the Arduino example debounce code to help us write our final code. To use the debouncing code, we were able to remove the Boolean components of our code because the alternating negating lead state lines fulfilled the same purpose.
Once we were done debouncing, the circuit and code were finished and we were ready to begin creating the sign. At first we were going to make a box-like sign so that the Arduino and circuit could slide inside. However, we changed our design so that it was a flat sign with a yarn looped in at the top to create a hanging sign instead. We then made holes for the LED and button and taped the circuit and Arduino to the back and wrote on the front.
We then began soldering by turning on the iron and waiting for it to heat. Then we got a PCP board and a circuit wire to solder together. We held the PCP in the stand and put the wire through one of the holes. Then we held the iron and soldering wire together next to the wire on the circuit, and the solder melted onto the board. This held the wire to the board.